Hey, what's going on, guys? KIM-1 here. Starting from this video, I want to try a completely new format for this channel. So I just downloaded an app that allows to record the screen on my smartphone, believe it or not. Yeah, so it's not new, but it's quite new for me. So in this video, I want to make a tutorial programming in 652 machine codes on a KIM-1 emulator that I've written on my own in JavaScript, and recently I've provided a mobile version for that emulator. And the benefit of this app is that I can switch the cameras and switch the desktop. So you can see me, you can see the code, and you can see the emulator in work. So without further ado, let's actually start. So here I got the code of the program that I was supposed to be writing in this video. So what the program is going to be doing, so just to give a little bit better understanding of what exactly the program is going to be doing, let me show you the development environment. So this is the KIM-1 emulator that we're going to be working with. And this, we have 6 digits here. Well, originally the KIM-ROM uses the leftmost 4 digits to display the data, and the 2 rightmost ones to display the four leftmost to display the address, and 2 rightmost to display the data available at that address in the random access memory. So now we're going to be writing a program printing 1, 2, 3, 4, 5, 6 on a display in 652 machine codes using the specific KIM-ROM function call that allow us to light up the displays with the specific values. So now let's get back to the code, and I just want to show the following thing. So right, here is the code. So we have the following key memory addresses. So we have FB, which would be lighting up this leftmost 2 digits. Then we have the FA. It would be lighting the second, and F9 is going to be lighting like the third 2 digits. And now the values. So we want to have 1, 2. Well, this is kind of the value of 11 basically. The value of 12, sorry. So on the leftmost, then in the middle, we want to have this 34, and then we want to have this 56 at the very end. So what we got here, so we want to load the instant value into the A register and store it to the specific value of store this value to FB. Then 34 store at FA, and 56 to store at F9. Then we call in the subroutine at the address 1F, 1F, and then we're jumping back to the initial address so that this happens in the infinite loop, and that's how we can see those digits on screen. So I hope this is clear. Now, without further ado, let's actually jump into coding. So first I want to go to the addressing mode, right? And I want to go to address 0200, all right? So what's wrong, 02? Yeah, let me just, all right. It was just a little bit laggy, probably because the video recordings were, yeah, 0200. And now go into the data. So our program starts at hexadecimal 200s, just a nice place for a KIM-1 program to start. And now I'm gonna be putting out the opcodes and talking through, because I just can't do the same as simultaneously showing you the code, because I see the code, but I would be typing the codes in and talking through it. So the very first thing to type in is A9. A9 stands for LDA, load immediate data, load data to the emulator register, and A9 is the opcode for the immediate addressing mode. So to the A register, we want to load the value of 12, like this. And then we want to store it. So to store the value of the 0 page, in this case, we need to use the opcode 85. And we're storing this to the address FB. And then we repeat. So now we want to say A9, load the value of 34 respectively, so 34, and 85 to store it to, this time this is going to be FB. It was FA, right? So this time I want to store it to FA. And finally A9 load the value of 56, so the rightmost two digits, and 85 STA 0 page address in mode to F9. So this, I'll walk through the code again. So for now, I just type this in. So the next thing to consider, I say 20, which stands, this is the opcode for subroutine, for jump to subroutine. So if I want to say jump to subroutine, say this opcode 20, and then address 1F, 1F. Well, since both bytes are the same, you don't see the difference, but actually 652 uses the little endian byte order, so you need to be aware of that if the address have different bytes inside. Alright, but here doesn't matter much. And finally, 4C stands for Unconditional Jump, and I want to jump to 200 hexadecimal. So now the little endian byte order makes sense. So first 00 and then 02, like this. Okay, so now let's get back to the addressing mode and say 0200 to make sure that it didn't mess up anything. So to the A register, loading the value of 12. Then storing this to FB, then to the A register, loading the value of 34 and storing it to FA, then loading to the A register 56 and storing it to F9. Exactly the case. 20 jump to subroutine 1F, 1F to display this, and then for C to 02, 002 to 200 hexadecimal. So far so good. So if I did everything properly, this actually now should result in printing like 1, 2, 3, 4, 5, 6 on the screen. So let's click go, and indeed we have this result. So this is quite satisfying. And if I want to stop the program, I need to say stop here. All right. Probably one last thing to demonstrate in this video is the single step in mode. Well, for such a simple program like this one, this might not be really on the cards, but for more complicated ones, this might be on the cards actually. So if I just go back to 0200, I enable the single step in mode. So this means that it will be execute once I press the go button, it will be executing one instruction at a time, and then we can inspect the values, so-called machine contexts. So those are the specific memory locations where the values of the registers are stored. So for instance, in this case, we can inspect the value that is stored to the A register. We could have inspected the values at the FB, FA, and F9, but still, since those are relying on KIM-1, they might be messed up during when I'm showing you this. So let's better go in and inspect only the register of the only the value of the A register, which is available as fixed memory address F3. So just press go, and it executes the first instruction and A9 12, which stands for load immediate data of 12, hexadecimal 12 to the A register. And if I now go to 00F3, we have the value of the A register being loaded there, and it's indeed 12. So far so good. If I want to return back to where the program counter is, I press this PC button, going back to where the program counter is. So far so good, and then I can press go again. So now we've stored this. Well, we can actually try to inspect the value of FB, but I'm not really sure that FB is going to be having exactly 12. Yes, because no, it's not 12, because the reason because KIM-1 is now working, and whatever is being displayed on the screen, that is actually the content of the FB. So actually FB prints that in FB we have the value of FB. So yeah, I mean not an FB. Well, but anyway, so we just can't really check that nicely. Just go back to the program counter where the program counter is better, and then go again, and yeah, now A register should be containing the value of 34. So let's check that, and it does. And then going back to program counter, so skip setting up, and finally now the A register should be having the value of 56, and indeed it does. Well, this is great. Well, we could have continued more, but yeah, let's just get back to the program counter, go. Now it would try to, yeah, now actually interestingly, yeah, it tries to display. But yeah, since there's a single step in mode, it doesn't really work that nicely. So yeah, here just can be demonstrated this way. So it did jump back, but yeah. So this program, since the display is used not only by the program but by the KIM-1 to actually edit the code as well, so it's not possible to debug that nicely. But if I just turn this off and let's say go back to 0 to 0 0 and just run this infinite loop, then now I can nicely see all the digits. So this is it from my side, guys. This was the very experimental video. This is the very first attempt, so please let me know in the commentaries if you like this kind of style of videos. Just a few words, like why am I doing this? I've already implemented a chess program relying completely on unsigned integers in C. That's the prototype, and I'm now working on porting that program to 6502 assembly and then ultimately to machine codes. And I'm kind of tempted to use my extended development environment for this emulator. It has a desktop version with a compiler, with an assembler, with an option to print out the hex dump and things like that. So kind of way easier to do, and I'm really tempted to use that basically. But on the other hand, my other part wants to go the hard way, and it actually wants to do everything like in the style that I've just demonstrated you. So in order to do that, so writing in machine codes is quite different from writing in assembly, because in assembly you can use labels, for instance, and if you just add in some lines of code, then the addressing are being automatically adjusted. But if you're writing this in machine code, so just to give an idea, so for instance, I got this code, but for instance, I want to add some line here. Then the addressing is going to be messed up. And let's imagine that this particular jump didn't go here, but for instance, it went here. And if here would be something different, and if this does affect the program workflow, this is going to end up in a complete disaster. So I need to change this absolute address. And if we're talking about the relative things, that's even worse basically. So yeah, it's quite complicated to write in machine codes directly. It looks a lot of look ahead work to make sure you know what you're doing basically. And there is a plenty amount of things, like very trivial things, like if you're writing in C, like creating a recursive function, for instance. It's also trivial doing it in assembly, but in machine codes, my brain is starting working very slowly. So first, I just wanted to get heads dirty, try to write at least something, and demonstrate you that. And I can't really say at this moment whether I would succeed actually with the chess program, because it's so huge. And again, like I'm so tempted to use the like extended development environment for that purpose, with an assembler, with a memory dump to have all of the debugging information. Because debugging just using this 6 digits, well, this is a hard way, this is hardcore, this is old school, but I'm not sure if I'm tough enough for that. So yeah, if I'm badass enough for that. So yeah, guys, this is it from my side. Thanks for watching. Let me know in the comments what do you think about this format, and take care.